All right, and so this is going to be the kind of demonstration. Everything is made in virtual reality. We have our hands, we have our controllers in place. We got microchip up top. We have all the different components over here on the wall, so the user can come in and kind of inspect it, what it look like in a giant form, what it would look like unassembled. So the idea being that if you start it here, you can kind of come from the top down. So this is already assembled for us, but we can basically get into it and you can see the little beam. You say, I want some of the smart components. So the smart components can include different software libraries that we may have that help control our LEDs, our push buttons, standard GPIO operations that are always going to be handled, some kind of a service handler that's put in place. Then you can have like your scheduler put in place. That's going to come out from the timer. The timer may be the 16-bit base timer, so timer 1. GPIOs can be claimed. So you're going to say, well, I have push buttons. So what are my push buttons? What pins do those go to? If I have different LEDs, what LEDs do those correlate? What are the different names and things like that? We use the ADC sensor, so on and so forth. So you basically can build kind of a system from the top down, and then virtual reality maybe represent that for a end user. So they can say, this is what I want, this is how I get there, these are the end components, and these are what may create those different components as the end product for me. So then you have your secure element. So that secure element can include, your encryption device, the ECC device. That can have your crypto authentication library. This is a software library. It's going to come in place. That leverages the foundation services to use I2C and communicate to the end hardware. So we can see which pins get claimed on the board or on the PIC device in the end, of course. You could probably configure that inside of a virtual environment, something like this, by having large devices that you basically map and say, well, from this pin, I want to go to that push button, and from this pin, I want to go to this connection switch and things like that. So it'd be relatively easy to program that logic inside of this infrastructure as well. So then if we want to be connected, we can have the Wink or whatever different, devices can get you in some type of wireless connection environment. And then that can get you into what software libraries may be used, which in peripheral needs to come in, and which one of those peripherals that you're going to have the different pins subscribed to. So in the end, you can basically say, well, the best product for you is going to see these different push buttons. This is the different sensors that you need. And this is a device for you. So you can say, well, a great prototyping board is going to be something like this. So this is the HPC Curiosity board. We can look at it again. You can see it's kind of basically the right dimensions that we're looking at. And so I can represent and get a feel for this board completely within a virtual dimension. And I can say, okay, well, this is kind of how big it looks. This is along the sides, different components along it. So then we can say, well, of those components, I'm going to go ahead and start assembling it. So I can put that first component on and say, oh, neat. Like I assembled that first component. That's what it's like to actually build up this board in this environment. So this is an existing board, but we could probably have some type of demonstration prototype board that you assemble inside of whatever order that you wanted. You basically just have to program the snap logic on here. So if we want to represent this board slightly differently, we actually can, and we can make it really unique. And we can say, well, put it on the purple connector, the blue connector, the brown connector, whatever it may be. So we don't need to be quite as boring as just, with a generic board that comes off the shelf. So you can put it on there, and then that can help distinguish different coding logics. And you say, well, this goes to this different component, and these are how these pins map to different ways and things like that. So you can have of that component some dynamic logic that does the mapping for us. So something similar with the push buttons. We can just kind of put the push buttons in place, things like that. So now we can have a board that looks completely different than what may have previously been represented. So we can put that one on there. It looks kind of like this. And you're like, all right, well, now we have a completely unique looking board that represents only something that I can see inside of my virtual environment, but it represents an end product that I can work with inside this area. So you can put the components on there, and I can turn on the LEDs and things like that, or I can put the different clicks onto the board and things like that. And I can say, well, this is how you assemble your prototyping board. These are what these push buttons are going to do for you. This is the different effects that you want to do. This is how you move through this demonstration and assemble the board in this manner. So you can do something like that instead of a demonstration environment. Put that the right side up. And so, I have a couple different markers here as well. We'll just throw those on the ground over there. So some of the other things that you can do inside of a virtual environment is say that I'm collaborating with a colleague here inside of VR. The two of us, we can say, well, I want to communicate. So I can say like, well, what's going on? Hi. And this isn't the best resolution, but obviously we can change it wherever we want it. But I was just kind of demonstrating the idea. That wasn't what I wanted to say. So let's go ahead and fix that. Let's get this one. There we go. And now we can have a specialized message, to whoever we may want to communicate out there, and then hide it. So if we have, a little bit more programming logic built into something like this, I can do flow diagrams, sequence diagrams, high-level architectural diagrams. We can write up which components we want. We can have the exact same whiteboard that we have in the office, but we can represent it in a virtual environment where different avatars can interact with each other. They can see each other's hands moving, things like that. And in the future, you'll eventually see, mouth movements and things like that. So that's just some of the different ideas that you can do here. So further is that if you have a user that has assembled this board, they've learned a little bit more about the components, they've learned more about what catalog exists inside of the entire platform, or inside, the whole catalog of devices that we may be able to support, we can go a little bit farther. So now we can go a little bit farther and we say, okay, well, this is going to be what an end device looks like. We basically have that end board. It's about the same dimensions that we'd expect that physical board to look like. I can look at it inside a virtual environment. I can look at it real close and see what it would look like for the different silk screen, all the different components, the LEDs, what kind of behavior I expect, or, I can make it represented in a much larger, easier to work with scale, so that we can analyze everything, or we can point out hard to see, solder pads and things like that that may exist inside the feature set for that board. And you can do all of it in a virtual environment. We don't actually have to send components out to individuals. They can see what that board will look like. We can demonstrate what that board's behavior is expecting. That doesn't look quite right. I don't like that at all. We'll get rid of that. So, we can evolve it a little bit further, and we can say, well, we took everything from these components and we demonstrated all the development of the libraries. We did all the basic demonstration with that development board. We actually did in Chandler. We did, MQTT library and all that such using the HPC Curiosity board and PIC18 device. And then we ended up migrating into the final hardware solution in the end. So it's basically the idea of taking something from prototyping environment, getting it to an end solution. We can walk everything through that. So the idea here is that we basically, if we ever need help with code, detailed designs, architecture, then, Microchip as a company can be there. We can help them use PICs, AVR, SAM devices, MCC, Start, MP Lab Studio, or Harmony is always going to be there. If they're limited on time and resources, then we have different options for them, and virtual environment can help break down some of the walls that lay in front of us as far as barriers of communication and things like that. Or being able to just demonstrate the basic application of a board. So we can say, okay, well, this is the PIC AVR IoT board, whatever it may be. If you power the board on, you basically are going to expect the LEDs to cycle. That represents if the hardware is behaving correctly. Now, if the LED is just in a static red state, then that basically is going to represent you in some type of hardware error state, or you're waiting for your connection. I mean, it really depends on the firmware version, but we could also demonstrate that for individuals. So the updated firmware version is basically going to say, well, if I don't have the red LED, then I'm going to basically end up seeing a blue blinking LED. Now, that blue blinking LED means that I'm trying to get some type of Wi-Fi connection, right? So I need to load the SSID, the password, whatever it may be, to gain access to my access point. So I'm just trying to get to my local access point, AP. It's all local. I can do a soft AP, whatever it may be. So let's go ahead and get our access point credentials. We would load that into the device. So, by default, that is MChip IoT. Microchip is the default password for the WPA2 connection. So we can kind of demonstrate that through an audio file or something like that as the user learns about it. And then they can basically say, well, that access point is really either being hosted by this Wink module, or we're loading the credentials into the Wink module to connect to the router or the access point of our local area. So if we've successfully done that, then that blue LED is going to go static, and then we're going to see that green LED start to pulse. It's basically indicating that it's now trying to establish a TCP socket connection. So we know to establish that TCP socket connection that we're going to, oh no, we're going to need to load our broker. I did it again. Our broker credentials inside of the device. So that's going to be basically our cloud broker credentials. So that's going to be basically the root certificate that exists on the Wink module. It's programmed in there on the factory. Or the end user, if they want to go to a different provider, can connect pins to this RX and this TX. That's going to give them direct communication to the Wink module, or they can apply the update to it. Using the existing solution out of Studio for updating the firmware and the root certificates and everything like that. So if they're in connection to their broker, then we're going to see that green LED go static. And then the LED is not going to come on yet. So we know at that point we kind of have a socket in place, but we're not connected inside of our broker completely. So we're going to want to be in a smart, secure, and connected kind of form. That, of course, is going to be supported by the ECC device. So that's going to allow us to have the JWT token that's necessary to get into the Google Cloud connection. And that's going to give us our smart, secure, connected kind of aspect of things. Now, if we were trying to do the AWS, then it's kind of a mix of the ECC device and the Wink for the different credentials and things like that. But generally the same kind of idea. So if we go a little bit farther, then now we're at the next step. So the yellow LED comes on, but it's not pulsing, so we're not sending that data. So what we're going to need to do is we're going to need to get connected to our actual MQTT broker connection. So once we get connected to our actual MQTT, then we'll get to our final stage, of course. That's a spoiler. But then at that final stage, we'll see that yellow LED start to blink, and that means that we're transmitting data back to the broker. The broker is sending data back to us, and that we're communicating as we expect. So that's kind of this general walk through the entire behavior you'd expect from this board. You can go into detail about the publishing and subscribing, basically sending information from the light sensor, from the temperature sensor, using I2C here, using the ADC sensor here, or you can have the different push button behaviors that affect it. You can go into deeper descriptions about how the yellow LED may become static on or whatever based upon a subscription that's received. But in general, you can kind of walk a user through everything. Now, further, in the future, the idea being that in a virtual environment, we can do rapid prototyping of boards that we build here. We can show what those boards may look like inside of different color schemes with different LEDs, different application behaviors connected to different brokers and things like that. But you can demonstrate all of that inside of a virtual environment where it's basically easy to program a lot of this logic in a fast, demonstratable way. And, this logic in particular, I programmed in C#. And so since it's C#, it's pretty close to embedded C, and so it migrates pretty quickly over into it. This whole engine itself, Unity uses C# as its base language, and then it uses a form of JSON or JavaScript, basically, so that we could easily bring different systems into parsing and things like that inside of that back leverage. And then it also has the Boo script, Boo being a form of Python script. So that would be able to parse through, device information and things like that. So once again, we can get back to our office and I can say, well, thank you for watching. I'm going to say, bye for now. The idea, again, just being that virtual reality can break down a lot of communication barriers. So if I'm working with a lot of offsite individuals or remote sites, and we can actually coordinate inside of a virtual environment. We can show what boards may look like without actually having that board physically in front of us. It still makes us get a feeling for, what this board feels like, what general behavior we're trying to go for. We can do a little bit more programming, make these push buttons do some type of different behavior over here. We can have the data demonstrated or shown in some type of different demonstration or, display inside of the virtual environment. We can have our rubber duck over here so that we can talk to this whenever we're trying to debug our code, or we can actually have our colleague come inside of our cubicle or virtual cubicle environment, and we can show them the code ourselves, and we can say, what's wrong with the logic right here? I'm just trying to do this different operation over here. Where did I go wrong? And then they can help us debug that code where it may be. So I actually did do that on purpose. This is supposed to just float in place. Let me see if I can get it. Oh, no. This is just the gravity off. There you go. So you can kind of get a little bit there. Let's see if we can throw something at it maybe. Oh. So, that's generally the idea. This is kind of what I made at Masters to demonstrate what it'd be like to have this type of new technology around us. You can have, whatever giant size of a monitor demonstrated and shown in front of you. So inside of our cubicle, we don't necessarily need to have all of the monitors taking up all that space. We can actually just have a virtual cubicle depending upon who we're working with during that week. We can just come into our virtual space. We can all be within our colleague area. We can be coordinating, be working with the code and things like that. And of course, in the future, when virtual headsets don't require computers and things like that, then laptops and things like that that are assigned to you as you join different areas can just be as simple as a headset. And then you can work in whatever remote environment that it may be. So that was just kind of the general idea. I thought it was easier to demonstrate and to show inside of a VR environment than it was to just talk about. So I kind of made this to do at an event, and it just kind of taught me a little bit more about programming as well. So that was it. Thanks for watching, guys.